Hi, I'm Kyle Cusick from Added Potential Math Tutoring. Today I'm going to be talking about a popular problem. You've probably heard of it, although maybe you haven't heard of it by its name, the Monty Hall Problem. See, Monty Hall was the host of the show Let's Make a Deal that was on decades ago, and he would pose this popular problem to contestants. There were 3 doors, behind 2 of which was something you didn't want, like a goat. Behind the third was something you did want, like your dream car. So your goal obviously was to try to get the car door. So you would randomly choose one of the 3 doors. The host, knowing where the car was, would then open one of the 2 remaining doors and then ask you, would you like to switch to the other remaining door? So the question is, should you stick with your original choice, trust your gut, or would it be beneficial for you to switch? So this has been a hotly contested problem in the math world ever since. This has been discussed on several shows and movies, like the movie 21, but I think it was more humorously discussed in the show Brooklyn Nine-Nine. So I'm going to play a clip from that. Okay, so let's explore the 2 possibilities. Let's see who's right, if Captain Holt was right or if Kevin was right. So one thing we can agree on is that before you make a selection, there's a 1 in 3 chance that one of the 3 doors is going to be the correct door. Now, what Captain Holt was saying is that once one of the doors is opened, there are 2 remaining doors, so there's a 1 in 2 chance that one of those doors is going to be the correct door. What Kevin was saying is that there's a 1 in 3 chance that you had it right to begin with, and a 2 in 3 chance that you had it wrong. Now, that 2 in 3 chance probability that you had it wrong was spread out over 2 doors, but once one of those doors is opened, this is what's called compressed probability. That 2 in 3 chance was compressed down to a single door. So there's a 1 in 3 chance that you were right and a 2 in 3 chance that you were wrong. Except that 2 in 3 chance, like I said, is now assigned to a single door. So who's right? Should you switch? Should you stick with your gut? Drum roll, please. The answer is that yes, you should switch. Sorry, Captain Holt, but Kevin was right. There's a 1 in 3 chance that you were right and a 2 in 3 chance that you were wrong. The key is in the fact that the host knows where the car is. He's not randomly choosing one of the doors to open. He knows which door the car is behind. So let's say, for the rest of these examples, let's say the car is behind door number 1. So if you choose door number 1, then he can in fact open either door 2 or door 3, leaving door 2 or door 3 as the remaining closed door. But now let's say you choose door number 2. He can't randomly choose one of the other 2 doors. He has no choice but to open door number 3, leaving the car door as the remaining closed door. Let's say you choose door number 3. He can't randomly choose one of the other 2 doors to open. He has no choice but to open door number 2, leaving door 1, the car door, is the remaining closed door. So if you chose one of the wrong doors, then he had no choice but to open the other wrong door, leaving the car door as the remaining closed door. Let's review that again. If you picked the car door, obviously the host will open either goat door, and leaving the other goat door as the remaining closed door, in which case clearly you should not switch. If you picked one of the goat doors, the host will open the other goat door, the other wrong door, leaving the car door as the remaining closed door. In that case, or in either of those cases rather, you should switch. There's a 1 in 3 chance you had it right to begin with, in which case you should not switch. There's a 2 in 3 chance that you had it wrong to begin with, in which case you should switch. What do you think? Does that make sense? If you're not convinced, don't worry, you're not alone. A lot of people are not convinced by this argument. So I came up with something else that might be helpful. Instead of using 3 doors, let's use 27 cards. So on a deck of 52 playing cards, there are 26 red cards. So take those 26 red cards and 1 black card. Have a friend take these 27 cards, lay them out face down, knowing where the 1 black card is. It's your goal. You get 1 chance to pick the 1 black card. Let's say you randomly select the card in the lower left. Your friend, knowing where the black card is, turns over 25 red cards, saying the black card is not one of these cards. Now the question is, would you like to switch, or would you like to trust your gut and stick with the original selection? So what do you think? Is it a 50-50 chance, or do you think you're increasing your chances by switching? I'm guessing that other card is looking pretty good right now. So there was a 1 in 27 chance that you were right to begin with, but there's a 26 in 27 chance that that other card is right, that the other card is the black card. So if the 3-door example wasn't convincing, hopefully the 27 card example was convincing. So let me know in the comments if you agree or disagree. Be sure to like and subscribe to this video. Look up Added Potential on Facebook and Twitter. And if you're looking for a math tutor, please drop me a line at addedpotential.com. We can start working on a curriculum that'll work for you. Thanks for playing. Hope to talk to you soon.